I'm going to start with the two examples that I haven't demonstrated from the last lecture. So the first example is how to use the built-in function fgetL. So fgetL is to get a line. That means you give you a txt file and let you read from the file. So fgetL is each time if you call fgetL, it reads a single line from that file. Okay. So last lecture I showed you an example. So the example is telling you now give you a temperature. So now I give you a temperature. So there's a 7 temperature. Okay. And then this stored in temperature.txt, and then ask you to write a MATLAB file to read from this txt file this line of temperature and calculate the average and print out the average. Okay, so here is the code. So first we called give the file name. Okay, define file name and use built-in function fopen to open this file and specify the mode is R, is reading from the file. And then we use fgetL, call this file ID. That means I'm going to go into this file and read this line. And then I assign this line to temperature. And then when I print out, I use this built-in function mean of temperature. That means average of the temperature. So here is the average. So it's 44.3. But if you go back to this line of temperature, it's nothing really above 44. Okay. So simply there's something wrong with this MATLAB code. So in fact, the mistake is from fgetL. So when you use fgetL, it went into the file and read a line, but it treats that line as a string rather than number. So then you use a mean this built-in function to calculate average. Actually, what you get 44 is the string's average. So that's where you made a mistake. So if you want to get the number's average, you're gonna use string to number. Okay. Change this read string and convert to number, and then it should work. Okay. So here you see the average temperature is 11. So that is sometimes a common mistake is when you use fgetL to remember string to number. Okay. This is the example that I think is worth demonstrating, and it's important. The other example that last time I didn't demonstrate, and I'm going to catch up here, is a simple MATLAB code to demonstrate artificial intelligence. So rather than I read from these slides, I'm going to demonstrate you here. So it's an interesting MATLAB code. Okay. So let's enter a name. Bob. So ask you have a number between 0 and 9. So give me a number between 0 and 9. 6. Okay, this is the small artificial intelligence MATLAB code. So let's read how does that made. So first, line 6 is display the whole thing. Pause for 1 second, and then you display again. Pause for 1 second, and then you ask for input. So input said who are you, and then specify the input must be a string. Okay, so you input the name. So then fprintf print out the whole sentence, and followed by the name. Okay, and then pause again, and then display this line. Okay, so then the following is to ask you input a number. So when you input a number, there's no specific argument followed. So if you don't put on anything, it's just the number as an input. And then fprintf. So here, why your input number is wrong. So every time I input a number, I assign to NUM, the variable NUM. And here said wrong, the answer should be, is actually a shifted version. If you give me 6, for example, plus 1 is 7. 7 modulo 10, you get 7. So whatever number you give to me, it's always shift 1. So you will never get the digit that you proposed. Okay? So this is a small demonstration, just to let you get familiar with DISP input fprintf. Okay? This is something that is interesting from last lecture. Last lecture is input output. You're going to understand how to use fprintf. So today's lecture, we're going to move to decision making. So decision making, it's subject to some certain condition. Okay? Under this condition, yeah, maybe I do this one. I'm going this way. Otherwise, I'm going the other way. So it's a condition. So here, anyhow, this is a small example of how do we make a flow chart. Now, I'm going into the detail how, first of all, when you make a decision, we're going to make a flow chart. Okay? So how do we make a flow chart? So we start from the first example. First example about triangle. Okay? So this length is input 1. Second length, input 2, asks you to compute the third size length. So it's simply input 1 square plus the other input square root. Take a square root. So we talked about this example before. Remember what we made is call the building function input. Okay? So when you input, for example, I will input 3 and assign to the variable ABJ. And then ask you to input another number. And then assign to OPP. And then finally, fprintout directly compute this and print out. Okay? So this is last lecture's example. But here, we may have a condition. So what happens if either one of the input had made you made a mistake, you input a negative value. Okay? So based on this example, we're trying to add a certain condition. The condition is to check your input whether it's negative or not. Okay? So here is the flow chart. So the flow chart, normally you can see the two different boxes. One is a square box. One is a rotated square box. Okay? So normally this is called flow chart for decision making. And this kind of rotated box is normally where you put condition. Okay? So let's say first is ask first input. Okay? And then you, under certain condition, under this condition, to check the first slide whether it's negative or not. If it's negative, print out error and exit. Otherwise, go on. Ask second input. And then go through the same similar condition to check whether this input is negative or not. If it's negative, print out error and exit. Otherwise, compute the final result. So how many conditions you have here? Just simply, you have two conditions. Okay? So the reason we like you to make a flow chart is just for clear out your logic. So based on this, now, based on this, we have two conditions. Now we're going to talk about how to write MATLAB codes to fit in this condition. This kind of condition normally we use relational operator to fit in this condition. Relational operator, for example, if you check an input variable, whether it's negative or not, so we put a relational operator in between. Okay? So relational operator is given here. You have less than, equal to, and so on. So there's two special one is double equal. Double equal means, for example, you give a variable A and B here. That means to ask you check whether A and B, they are equal or not. Okay? And this tilde equal, this to check whether A and B not equal or not. Okay? So under certain condition, you compare two variables. Can be two variables, can be vectors. You make a comparison, and you're going to judge whether this comparison is true or false. So this is the relational operator. So relational operator, it returns you a different data type called logical data type. So about data type, we have studied how many? We have studied double. Double means real numbers, 1, 2, 3, 4, 5, 6. Okay? And we have studied string. String means, for example, can be some letter, can be some number with a single quotes. Okay? This we have studied just last lecture. This is the third data type. It's called logical. So this logical is related to the relational operator. As I said, relational operator is for you to compare these two things, whether they are equal, whether greater than or less than. Okay? For this kind of comparison, normally the comparison, the outcome either can be true or false. If it's true, we represent this outcome using 1. If it's false, we represent by 0. Okay? So you see a bunch of 0 and 1s. If it's a logical data type, it means the comparison either true or false. Okay? So let's take an example. Let's see this example. So A was assigned a vector 3, 5, 7, 9. And the first example is A compared with 5 under this condition, greater than. So how do we do it? So what MATLAB will do is you compare each element in A with 5 under this condition. Okay? So for example, first 3 compared to 5. Is 3 greater than 5? False, right? This comparison is false. And then second, 5 greater than 5, false. Okay? 7 greater than 5, true. 9 greater than 5, true. And then you replace false by 0. Okay? True by 1. So this is the result you get. Okay, this is called logical data type. So this is one application of relational operator. So any question? Feel free to ask. Okay, then we compare, that example is a vector with a number. So now we compare two vectors, A and B, okay? And when you compare two vectors, they must be the same size. Otherwise, you can't compare, okay? So the first example is ask you compare A and B under this condition. That means compare each element of A with each element of B under this comparison. This comparison is not equal to, okay? So now, first we compare 5 and 2. They are 5 not equal to 2. So it's true, okay? And then the second, 4 and 4. 4 not equal to 4 is false, okay? And 3 and 6. 3 not equal to 6, okay? True. And the last one, 2, 8, 2 not equal to 8 is true. Okay? So you represent true by 1, false by 0. And here is what you get. Okay? So you basically apply the same logic. You can practice the leftover the examples. So I'm just going to explain the first one. So this is a relational operator. Relational operator, as I said, this double equal to. It doesn't mean assignment. If you have single, this means assignment. If you have double, it's normally compare A and B, whether they are equal. Okay? So one is a relational operator and the other is not. So this is compare A and B, are they equal or not? If you have a single equal to, this means you assign B everything to A. Okay? So let's say an example. A and B are given. They have the same size. Okay? So if you say A, B, are they equal? So what you're going to do is you compare each element of A with B. Okay? Element by element wise. 4 and 2 equal. No, it's false, right? 2 and 2 equal true. 0, 2 equal false. So false replaced by 0, true replaced by 1. However, if you say A equals B, that means we assign B to A. So B is 2, 2, 2. When you assign to A becomes 2, 2, 2. Okay? So this is different. Okay? So any question at this point? We're all good. Okay, that is relational operator. Relational operator is to compare two things. So now we move on to logical operator. Logical operator is a connection of relational operator. Imagine you have a multiple relation operator. For example, A greater than 2, B greater than 3. Okay? This is called relational operator. You compare two things. And logical operator is normally connection. Okay? You can put and. These two conditions must be both satisfied. Okay? Or logical operator, you can put or. This line means or, means either one of the conditions can be satisfied. Okay? So this is called a logical operator. It's a connection between the two conditions. So logical operator, we have and, or. This means invert or not. So there's a truth table here. Truth table is, we can understand this way. Giving you A, B, okay? Either 0 and 1. So we say A and B means both of them are 1, then you get 1. Both of them, you can understand, both of them are true, you get true. Okay? If it's or, is one of the condition is true, is true. Okay? And the not, or we call it invert, is the false will become true, true will become false. So 0 becomes 1, 1 becomes 0. Okay? This is the idea of logical operator. Let's see an example. So this logical operator, for example, we see this first example. This example, you have two conditions, and you use and to connect them. Once you use and, that means these two conditions must be both satisfied. So x greater equal than minus pi, or less or equal than pi. So something in between. Okay? So this is and. So the next example is or. The first condition, second condition. So these two conditions, either one of them satisfied, then the outcome will be true. So it's saying why either this true or this true, or okay. Okay? So inverting is very easy. Inverting is just, if you get 0, you turn into 1. If you get 1, you turn into 0. Okay? So let's see an example. This is logical operator. So now logical operator compare two matrices. One is A, one is B, and they must have the same size. Okay? So now, the first example is A greater than 2 brackets, and in front you have not. Okay? So there is some priority. So if you see brackets first. Okay? So we first compute this part, A greater than 2. So now we check each element. Is 2 greater than 2? So it's false. So false, we put 0. Okay? 4 greater than 2, true. 6 greater than 2, true. 8 greater than 2, true. So this is A greater than 2. This is the outcome. But then you have a not in front. A not in front means 0 will become 1, and 1 will become 0. Okay? So this is what you get. Okay? So this is the basically a combined version. Now this is the first example. The second example, is still brackets A greater than 2, and in front you have 2 invert. Okay? Always say 2 not. If these 2 invert meet together, they're together, so they cancel out each other. So this is equivalent with, say, A greater than 2. So it's basically 0, 1, 1, 1. Okay? So up to this point, any question? Okay, all can follow. If you can follow, then I move on to next topic. Next topic is, so basically these 2 topics is to give you, to set what's the condition, okay? Either comparison or multiple comparison combined. So now, now we follow an example. This example is it's interesting. So this example, let me explain to you. This is giving you a vector to A, and then you call this logical. Logical is a building function, followed by a vector 0, 0, 1, 1, 1. If without this logical, this is just double data type. It's just 0 and 1s. But if you put a logical here, then you convert this double to a logical data type. That means if you put logical here, this building function is going to convert this double sequence into logical. Sorry. So that means 0 means false, 4, 2, 2, 2. Okay? So you're going to convert them into the logical data type, and then assign to index. So the index is going to be a logical data type vector. So when this vector use this index, it's going to return the value in A which are true. Okay? The last 3 digits are true. So you're going to return 2, 0, minus 2. Is that clear? So, similar idea. This is telling you logical data type as an index to a vector. Okay? Now apply the same idea to this example. So ask you to write a single line that get all value from A, which are less than 1. So this is condition. You have 2 conditions, less than 1 and greater than 1. Less than 5 and greater than 1. So let's write down condition first. Less than 5 and greater than 1. So you want both of these conditions satisfied. You put and. This both conditions satisfied. But this is gonna, like what I said, give you an index. This will give you a logical index. So then A, you use this logical index that will give you the value of A which satisfies this condition. Okay? So this example, similar idea with the last example. Okay? It's using logical data type to be indexed. So at this point, any question? Okay. So that is telling you condition, comparison, whether it's true or not. Now, we have this condition. We know how to write this condition. How do we make MATLAB codes? We take advantage of this kind of condition. So first command that we're going to use is if statement. If statement is saying if followed condition. If this condition is satisfied, we do this command and then go on. Okay? If it's not satisfied, we skip this whole part and continue. So if statement, if you use if, you must use and. This is a pair, like F open, F close. It's a pair. Okay? And we notice this if condition is only one condition. Okay? So this is if statement. Now, similarly, okay, before that, I give you an example. This example is to saying this is self-document clear as we input a number. For example, I input 3. So then assign 3 to this variable number. Okay? And then judge if the input is less than 0. So what I input is 3. This condition is not satisfied. Okay? So if it's not satisfied, skip. And then skip if statement and to the continue. So you display end of M file. However, if I input -3 here, so if -3 is less than 1, this is satisfied. Then display the number is negative and continue. Okay? So here I can demonstrate you. So for example, I input 10. Okay? So basically, this condition won't be satisfied. Okay? If it's not satisfied, and then you display this. So now, let me input -10. So it's going to print out this, and then continue with this. Print out 2 things. Sorry. Whoops. So here's a simple example of if statement. Now we use if statement to write this MATLAB code. Still the triangle case, and ask you input whether it's negative or not. So these 2 conditions, we're going to use if statement. Let's see how we do it. So imagine the first input is called ADJ, second is OPP, and you just if followed by condition. This input less than or equals to 1, to 0. And giving these 2 conditions, let's write a MATLAB code. So I will skip the rest I just talked about here. Okay? So if this condition is satisfied, when you write an if statement, as I said, you have n. If statement, you have n. Okay? So if the input is negative, what do? You print out error and exit. So here, when you print out error and exit, I'm introducing you a built-in function. So this built-in function called error, followed by a line of text. So this built-in function can do 2 things: print out error and exit. Okay? So this is built-in function called error. So this is the entire demonstration of how do we write condition comparison using if statement. So here, actually, the slide is saying you have an indentation. Indentation means you have a space here. So this space is for you to easily visualize everything. Okay, actually, this indentation, this space is not is actually naturally created by MATLAB. So when you make an if statement, you will see it naturally have some certain space. So this is some good programming skill. Now we talk about if statement to make a condition, and a slightly more complicated structure. Second structure is called if-else. It's similar to if statement. If statement is saying if condition, then do something, okay? And then end, okay? So this is only one condition, okay? Only one condition. So if-else is also one condition. If this condition is satisfied, do this. Otherwise, do something else. It just giving you one condition, give you two solutions, okay? If this condition satisfied, we do this. Otherwise, we do something else. So this is if-else, okay? They both have one condition. But now we have the problem is what happens, we have multiple conditions. This is normal, in normal life, normally we have more conditions, okay? Not only one condition, multiple conditions. So here, you can concatenate if-else. So you see here, if followed one condition, else if followed another condition. So you can nest them, if-else, okay? But this thing is, I wouldn't suggest you to do that, because normally what we do is combine else if together, okay? Which is more efficient. When you have multiple conditions, you use if-else if. Else, okay? So this is third type of the statement, and in this statement is you have multiple conditions. So this is saying if this condition is satisfied, then do this command. Otherwise, and check if second condition is satisfied, and do this command too. Otherwise, both conditions are not satisfied, and do this command, okay? So this is two conditions. What happens if you want to add more condition? You may have 4 or 5. So you can, before else, you can add else if, condition 3, okay? And then command 3, okay? So you can keep adding multiple conditions. So this is if, else if, okay, to deal with multiple conditions. Let's see an example. So this example, I give you 1 minute to read the example. Okay, so this example is to saying, ask you to input a grade and then print out whether your grade is HD or D or C or pass or fail. Now we have multiple conditions. So here is the flow chart. Okay, so the flow chart. Now first you have an input, and then you list all possible conditions. So what is condition? First condition is greater than or equals to 80, and then 70, 60, 50. The last condition fail, you can just ignore it because you can use otherwise else. Okay. To summarize, all the input didn't satisfy all the above 4 conditions, it will go to the last one. Okay. So if this is correct, if it's yes, then print out HD. If it's no, go to check the second condition. Second condition, if it's true, okay, print out D. If it's not true, okay, check the third condition. And you repeat, okay? And the last one, the 4 condition all didn't satisfy, the last one directly print out fail. Okay, this is the flow chart of the idea. Now, according to the flow chart, we can make a MATLAB codes. So basically, you have a full condition. You have multiple conditions. What do you use? You use if, else if. That allow you to have multiple conditions. So here is if, else if. Okay, so imagine your input is called grade. So this condition is checked whether it's above 80, then print out HD. Otherwise, check whether it's 70 above, print out D, and so on. The last one, print out fail. Okay? So this is the if-else-if structure. And now we add some self-documentation and add display, add input, make it complete a MATLAB code. But in this MATLAB code, it's correct, but it just have a weakness that you always use fprintf. So we have like 5 conditions you use 5 times. You call 5 times fprintf. So in fact, we can improve this MATLAB code a bit more efficient by replacing this. Using this idea. So how do you only use fprintf once, not 5 times? So what you're going to do is you assign fail, for example, the last condition, fail, to the variable called converted grade. Okay? So by default, this variable is fail. And then you have an input called grade, and then you just check the grade. Whether it's above 80, it's above 80, you overwrite the converted grade. Previously, it was fail. Now, it's new condition satisfied. Then you update by HD. So if it's not satisfied, go to second condition. If it's second condition is satisfied, you update this variable by D, and so on. So at the end, you just print out this variable converted grade. Okay? So if all this above condition is not satisfied, then you just print out convert grade by default. So that means failed. Okay? So this is the, in such a way, you only use fprintf once. But both of the MATLAB codes are correct. It's just that this one is a bit more efficient because you only call fprintf once. Okay, so here is the entire MATLAB code that the later case, the efficient one. Now, facing this, we have one more condition to ask you. So ask you to modify this MATLAB code to add another condition, one more condition. If your input is above 45, then we say you're near pass. Okay? So how do you add one more condition? Any idea? Add one more condition. Add one else if here. Okay? If you need to put more conditions, stuff them in, just use another else if. So if grade greater than 45, print out near pass. Okay? So here is the MATLAB code. I'm going to give you an idea. So here I already add this near pass case, this condition. So now let's run this. So let's say I'm 40. I gave 40. Huh? Fail. And here we can say 60. So this is based on decision-making condition. You can have multiple different printout. So this is a very easy case. Now we will briefly introduce the last example. The last example is giving you 4 digits as password. For example, 1337 as a password. And someone gonna input some digit. If it's match all password, it means the system unlocked. Otherwise, it print out error. So when you input digit, you're gonna check all these 4 digits, whether they are all matched or not. If they are all absolutely yes, go unlock. Otherwise, anything went wrong, print out error and exit. So this is a very straightforward example. Okay? So the first solution, they use the if-else. So this stands for indentation. So you can clearly see you use the for if-else. Okay? So the reason you use for if-else is because you have for condition. Check each of the input, whether they are match your password or not. So the password is 1337, and then the first condition is check first digit, match to the first digit of password, and so on, second, third, fourth. If it's all satisfied, display unlock. Otherwise, anything wrong, display error, and exit. So you use the for if-else, and they are kind of nested. Okay? So this is nothing wrong, but it's inefficient. Because when you have this, first you understand this condition is for condition, and they must be satisfied. So instead of you using this concatenated thing, we can use for condition. For example, this for condition, and they all satisfy. What do you use? You use and. Okay? If they are all satisfied, then it's okay. Then you display. Otherwise, you print out error and exit. So here I'm going to show you example. So you can just put the first condition, you use and, second condition, third condition, and fourth condition. Okay? So for example, so any one of the input didn't match, it won't print out error and exit. Okay? So this is the if statement using and. But there is a problem when you use and. Okay? So when you use and, if you have, for example, like what we said, for condition, what MATLAB will do is you check this condition. If it's true, check second condition. If it's true, third condition, not true. Fourth condition, true. Okay? You have to check all possible conditions, all four conditions, and then find out, oh, they are not okay, and exit. Okay? This is AND operation. So is there anything better than AND that we can make this condition more efficient? So we instead of putting AND, you can put double AND to replace AND. So this double AND is called a short circuit operator. So what does this double AND, the difference is if you check here is true, here is true, the third condition is false, and directly jump out, okay, exit. It will, as long as one condition is not correct, it jump out, okay? It's not like AND have to check out the whole thing no matter true or false. At the end, he make a decision, okay? So this is called short circuit operator. And this short circuit operator is more efficient than this simple AND. But there is a limitation. This limitation is here. So the short circuit operator can only use if statement and can only operate with scalars, cannot compare with vector. Vector, if you compare with vector, you have to use AND. Okay? So this is a limitation, but it's faster if in if statement. So that's pretty much